Good morning to all. Here in a second year, we are going to start the important chapter, that is matrices, matri, matrices. But before going to start this matrices, but what is the meaning of a matrix? What is the meaning of matrix? But what is the matrix? What is the meaning of matrix? Matrix is an arrangement of, it is an arrangement of matrix is an arrangement of real or complex numbers matrix is an arrangement of real or complex numbers in rows and columns. So matrix means it is an arrangement. Matrix is an arrangement of real or complex numbers. It's arrangement of a real or complex numbers in rows and columns. Rows and columns. So this but we don't have a complex numbers is not our syllabus. So we have to consider only here real matrices. The real matrices means a matrix in which all the elements are which numbers? Real numbers. So here matrix is an arrangement of a real or complex number in rows and columns. If you see the example here, next, what is the meaning of order of the matrix? Order matrix means it is arrangement of rows and columns. It is an arrangement of a real or complex numbers in rows and columns. But what is order of the matrix? Order of the matrix. What is order of the matrix? Order of the matrix is give number of rows order of the matrix is gives what number of rows and columns. If matrix has m rows and n columns, then order is you read it as m by n. You read it as m by n. Order of the matrix is gives what? Number of rows and columns. Order of the matrix is gives number of rows and columns. If matrix has m rows and n columns, then order is gives what? M by n. So that means the example you see here, this is A is the matrix 1, 2, 3, 0, 1, 5, 2, 1, 7. So what is the order? Order of the matrix means what? If the matrix has m rows and n columns, then order is gives what? M by n. M by n means m is gives number of rows, n is gives number of columns. Rows means horizontal lines. Rows are which lines? Horizontal lines. Columns are which lines? Vertical lines. vertical line. Rows, horizontal lines are gives rows, vertical lines are gives column. Here how many rows are there? 1, 2, 3. 3 rows are there. By next you write down the columns are not. What are the columns? Vertical line 3. So that's why it is a which matrix? 3 by 3 matrix. It is a which matrix theorem? 3 by 3 matrix. But all the entries in this matrix are what? Real number. All the entries in this matrix are which number? Real number. That's why A is called as a which matrix? Real matrix or not. That's why A is called as a which matrix? It is a real matrix. So next order of the matrix, this one. Next dimension of the matrix. Dimension of the matrix. Dimension of the matrix means what? Number of elements. Dimension of the matrix means what? Dimension of the matrix is number of elements in the matrix. Dimension of the matrix is what? Number of elements in the matrix. Dimension of the matrix is gives what? Dimension of the matrix is number of elements in the matrix. If matrix has m rows and n columns, if the matrix has a m rows and n columns, then dimension of the matrix is dimension of the matrix is mn. So dimension means what? Number of elements in the matrix. Actually matrix is, it is an arrangement of a rows and columns. Which we are arranging here? Entries or elements. It is a real or complex number, or maybe any alphabetical also. Elements which arrange in a rows and columns. And not only real or complex numbers, or any alphabets also. Number of rows and columns is gives order of the matrix. If the matrix has a m rows and n columns, then order is a m by n. You must read it as m by n. Here rows are horizontal lines, columns are vertical lines. But the dimension of the matrix, dimension of the matrix is number of elements in the matrix. If the matrix has a m rows and n columns, then dimension of the matrix is gives m by n. Now remember that here I said the matrix is what? An arrangement of a real or complex numbers in a rows and columns. Not only real or complex, or if you need some alphabets also, you can arrange in rows and columns. So A is the matrix, the 1, 2, 3, 5, 3, 2, 0, 1, 1, 1, 4, 5. What is its order? First you write down the rows. Rows is gives. First you write down the rows. Rows are horizontal line. How many horizontal lines are there? 3 by columns 4. So that's why matrix is a which matrix? 3 by 4 matrix or not. It has a 3 rows and 4 columns. So what is the dimension of the matrix? dimension of the matrix. What is the dimension of the matrix? Dimension of the matrix is gives what? Number of elements in that matrix or not. Dimension of the matrix is gives what? Number of elements in the matrix. Here we have a 3 elements. A dimension of the matrix is gives what? Here we have a 3 rows. Each row has a how many elements? 4 elements. So dimension of the matrix means just it is a product of number of rows and number of columns. So it is gives what amount? 12 or that. Dimension means how many number of elements are there in the matrix. When the matrix has a m rows and n columns, then dimension of the matrix is gives mn. Mn is equal to what? 12. Next. Location of the element. Location of the element. Location of the element. Location of the element, the matrix, and representation of matrix, and representation of the matrix. Location of the element in the matrix, representation of the matrix in compact form. Compact form means simplest form. For example, A is the matrix which you can write down like this one. A suffix ij m cross n. So what does it mean? This A suffix ij is the element which is located the intersection of ith row and jth column. Aij is the element where it is located, Amma. It is located in the intersection of a ith row and jth column. That means Aij is gives what? General form of a element or not. This is what? General form of a element. But here m is gives what? Number of rows. In this A suffix ij, the first suffix is gives represent a row, the second suffix is represent a column. Here the order of the matrix is what? Here m by n or not. Order of the matrix is m by n. Here number of rows are m means I takes the values from where to where? 1, 2, 3 and so on m. It represent what? It has a m rows. J is gives what? Column or not. In the matrix, how many columns are there? N columns. That's why J is gives 1, 2, 3 and so on n. This is the simplest way of representing a matrix. Just I represented A is equal to Aij m cross n. So this, don't say it is a m cross n, you call it is a m by n. Read it as m by n. That means what? It has a m rows and n columns. Aij is gives what? General form of a element. General form of element. So here in this subscript, the first one is gives a rows and the second one is gives columns. Then Aij is gives the intersection of a ith row and Aij is the element which is located the intersection of a ith row and jth column. For example, if we take here A is a 1, 2, 3, 4, 0, 5, 1, 2, 3, 1, 7, 2, like that is there. It has how many horizontal lines? 3 horizontal lines. So the horizontal lines are gives rows. That's why 3 rows by vertical lines 4, that is a 3 by 4. So what is the order of this matrix? 3 by 4. If it is given to M, A23 is asked to you. That means what? What is A23 element in this matrix? But A23 means what? A23 element, where it is located? It is located in the intersection of a second row. This is the second row. And where? Third column. This is the third column. Second row and third column, where they intersected? Here or not? That's why its value is 1. If it is asked A31, what is that A31 element? A31 element is the intersection of a third row. This is the third row and first column. This is the first column order. What is the third row and first column intersection? 3. That's why A31 is used what? 3 order. This is the location of the matrix. Next here, dimension is used what? Dimension of A is used what? 3 into 4. That is equal to 12. This is the location of the element in the matrix and representation of the matrix in compact form. Compact form means simplest form. So this way you can represent your matrix in a simplest form. Here A suffix ij is used, general form of a element. A suffix ij, element which is located. A suffix ij is the general form of a element. But this A suffix ij is represent what? It is the element which is located in the matrix at the intersection of a ith row and jth column. The suffixes, the first one is represent a row, second one is represent a column. But first one has a row, second one is represent a column. So here how many rows are there? M rows are there. That's why I is a takes from where to where? 1, 2, 3 and so on M. J is gives what? Represent a column. How many columns are there? N columns are there. That is the dimension of the matrix. And next one is a zero matrix or null matrix. Zero matrix or null matrix. Zero matrix or null matrix. So before that we look at here square matrix and rectangular matrix. 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 What is the meaning of a square matrix? Square. The shape of the matrix is a square shape. In a square, generally we know that length and breadth is the same or not. In a square, generally we know that length and breadth is what? Same. So similarly here the meaning of a square matrix is what? Square means here number of rows and columns are same. Square matrix is a matrix in which number of rows is equal to number of columns or number of rows is equal to number of columns. Square matrix is a matrix in which number of rows is equal to what? Number of columns. in this case, in this case, order of the, in this case, order of the matrix is, in this case, order of the matrix is, in this case, order of the, in this case, order of the matrix is, gives number of rows. That means what? What is the meaning of a square matrix? Square matrix is a matrix in which number of rows and number of columns are what? Same. Number of rows is equal to number of columns. But in this case, order of the matrix is gives what? Number of rows only. So that means what here? For example, if we take A is a 2 1 5 3 2 1 0 1 5 order. This is a 3 by 3 matrix. Here rows and columns are what? Number of rows and number of columns are what? Same order. Here we have a 3 rows and 3 columns. If you see the shape of the matrix, it looks which shape? Square shape order. That's why the matrix is a which matrix? Square matrix. But in this case, how can we say the order of this matrix? We can say simply it is a third order matrix. Simply we can say it is a which matrix? Third order matrix. Why? In the case of a square matrix, the order is no need to write order is a 3 by 3. Simply we can say that the order is number of rows in the matrix. Here 3 rows are there. That's why it is called as a third order matrix. Rectangular matrix. Rectangular matrix means elements in the matrix are in which form? Rectangle shape or not. Elements in the matrix are in which shape? Rectangular shape. So rectangular matrix is a matrix in which number of rows not equal to what? Number of columns. Rectangular matrix is a matrix in which number of rows is not equal to number of columns. Rows and columns are not same. Then matrix is a rectangular matrix. Means what? Shape of the matrix is a rectangular shape. In generally rectangle means what? Length is not equal to breadth. So similar way here, number of rows not equal to number of columns is gives a rectangular matrix. So what is that you look at here? A is equal to 1, 2, 3, 4, 1, 5, 7, 0, 2, 3, 1, 7. Here we have a 3 rows and 4 columns. That's why it is a which matrix? Rectangular matrix. If the matrix is a rectangular matrix, then you call order of the matrix is 3 by 4. If the matrix is a square matrix, order is gives number of rows. If the matrix is a rectangular matrix, order is gives number of rows by number of columns. Now this again this rectangular matrix is classified how? Rectangular matrix again it is classified into 2 ways. Rectangular matrix is classified in 2 ways. What is that? Horizontal matrix. Horizontal matrix. Next one is what? Vertical matrix. Horizontal matrix. And next one is what? Vertical matrix. Rectangular matrix is split as horizontal matrix and vertical matrix. What is the horizontal matrix? If if number of rows less than number of columns, matrix is horizontal matrix. Matrix is horizontal matrix. If number of rows is less than number of columns, then matrix is a which matrix? Horizontal matrix. Rows less, but columns are more, means this is the horizontal or not. Number of rows less than number of columns, then matrix is which matrix? Horizontal matrix. See the example 1, 2, 3, 4, 2, 1, 5, 7, 2, 1, 0, 6. So here 3 rows and 4 columns. Here rows are 3, columns are 4. That means rows is less than columns. That's why see the shape is a which shape? Horizontal shape or not. Shape of the matrix is how it is? Horizontal or not. Because of rows are less than columns. Vertical means if number of rows greater than number of columns, if number of rows greater than number of columns, then matrix is vertical matrix. If number of rows greater than number of columns, then matrix is a vertical matrix or not. Then matrix is what? Vertical matrix. Whenever the number of rows is greater than number of columns. If you see here, A is the matrix 1, 2, 3, 4, 5, 7, 6, 2, 1, 1, 0, 7 here. Here how many rows are there? Rows means horizontal lines. 4. How many columns are there? 3. That's why it is a 4 by 3 matrix. Here rows are what? Greater than columns. That's why it's look like a horizontal matrix. Horizontal means shape is like this. Vertical means like this. Horizontal means rows are dominating. Vertical means rows are dominating. Horizontal means columns are. If you are moving like this, columns are dominating. If you are moving like this, rows are dominating. Rows domination means vertical. Columns domination means horizontal order. That's why it is a vertical matrix or horizontal matrix means this one. The shape also looks that shape one. This is the stretched this horizontally. Here stretched vertically on. Here the shape is stretched horizontally. Here shape is stretched vertically. That's why it is a vertical matrix. This is a horizontal matrix. Stretched vertically means rows are increasing. Stretched horizontally means columns are increasing order. Next number zero matrix. Zero matrix is a matrix in which all elements are zero. Zero matrix is a matrix. This zero matrix is also called as a null matrix. Is also called as a null matrix. Zero matrix or null matrix is a matrix in which all elements are what? Zeros are. In which all elements are what? Zero. So the example, if you see A matrix is 0, 0, 0, 0, 0, 0, 0, 0, 0. It is a square matrix of order 3. If we take like this, it is a 0 0 0 0 0 0 0 0 0 0. It is a 3 by 4. It is a rectangular matrix. But all the entries or elements in that matrix are what? Zeros. That's why it is called as a zero matrix. Null matrix or zero matrix. Is that horizontal and vertical null matrix? What is rectangular matrix? What is a square matrix? Square matrix means order is gives the number of rows. Rectangular matrix means we can define the order like this, m by n, rows and by columns. While reading it, don't read it as a cross, you read it as a by. Next one is a singleton matrix. Singleton matrix. Next one is a singleton matrix. What is the meaning of a singleton matrix? Singleton matrix is a matrix which has only one element. Singleton matrix is a matrix which has only one element. A matrix has only one element, then the matrix is called as a singleton matrix. It is the singleton matrix example see here. Two. This is the matrix consisting of only one element or not. Now it is a which order matrix? It has only a one row, as well it has only one column. That's why singleton matrix is a first order matrix or not. Next, B is equal to what? Minus 3. This is also a singleton matrix or not. The matrix which has only one element is called as a singleton matrix. Next, diagonal elements. So what is the diagonal element? Diagonal is possible only in square matrix. Only in square matrix. Diagonal is possible only in which matrix? Square matrix. So diagonal elements means what? Diagonal elements means what? Diagonal is possible only in a square matrix. Diagonal is possible only in a square matrix. So if I consider a square matrix like this, first I am going to considering only 3 by 3 matrix, since our syllabus is confined to only 3 by 3, not more than that order. So if I consider a diagonal is possible to only square matrix or not. If I consider a square matrix like this, A11, A12, A13, A21, A22, A23 and A31, A32, A33 or not. As you aware of it, it is a which matrix? 3 by 3 matrix means a square matrix or not. So it has a 3 rows and 3 columns. When the shape is look like a square, then the diagonals, how many diagonals are possible? See, this is the topmost here, corner bottom. So this is also a one more diagonal, in general is possible. But this diagonal is called as a non-principal diagonal. This is a which diagonal? Non-principal diagonal. This is a non-principal diagonal. But this is called as what? Principal diagonal. This is called as what? Principal diagonal. This is a non-principal diagonal. This is called as a principal diagonal. The meaning of a diagonal is The meaning, when you use the word diagonal, we consider only a principal diagonal, but we never consider a non-principal diagonal. The meaning of a diagonal is only principal diagonal, but should not consider any other. So this is the principal diagonal. So what is the diagonal elements are what? A11, A22, A33 are called diagonal elements. So diagonal means we consider only which elements? So diagonal means we consider only principal diagonal elements. So what is the principal diagonal elements? A11, A22, A33 are called as a diagonal element. So what does it mean? In a matrix, if we have a elements of the type Aij, if we have a elements of the type Aij gives principal diagonal if I is equal to j. This is the general representation of a matrix or not? In this matrix, what is the general element? Aij. When Ai is a general element, what are the principal diagonal elements means? This Aij gives a principal diagonal elements whenever I is equal to what? J. So what does it mean? A11 Ij same or not? A22 Ij same. A33, A44, A55, A66 and so on, Ann. If it is a third order matrix, A11, A22, A33 are principal diagonal elements. If it is a fourth order matrix, A11, A22, A33, A44 are principal diagonal elements. If it is a nth order matrix, A11, if nth order matrix, nth order square matrix, because the diagonal is possible to only principal diagonal elements. If A is nth order square matrix, A11, A22, A33 and so on, Ann are what? Principal diagonal elements. They are what? Principal diagonal elements. Principal diagonal elements. Or a principal diagonal element. So this is the diagonal element form. Next, above the principal diagonal and below the principal diagonal element. Above the principal diagonal, below the principal diagonal. If you see here, A11, A12, A13, A21, A22, A23, A31, A32, A33. If this is a square matrix or not? Because of a square matrix, we can decide a principal diagonal here or not. So this is a principal diagonal or simply a diagonal. These elements are what? Above the principal diagonal. These elements are what? Below the principal diagonal. But generally the matrix, I have already told you that, can represent in which way? In this way, simplest form. If it is a 3 by 3 matrix, I is takes 1, 2, 3, J is takes 1, 2, 3 or not. But these are the elements where they lie. They lie above the principal diagonal or not. These are the elements where they lie. They lie below the principal diagonal or not. But in the case of a above the principal diagonal, clearly you observe that I is less than j or not. In all these cases, 1, 2, 1 is a row, 2 is a column. So 1 is a I, 2 is a j. Here what happened? I is related to row, j related to column or not. That's why A12, A13, A23 means here I is a less than j. In this cases what happened? I less than j. In this cases, what happened? I greater than j or on the principal diagonal I is what? J or not. So that means if the elements are on the principal diagonal, I is equal to j. If the elements are above the principal diagonal, I is less than j. If the elements are below the principal diagonal, I is greater than j or not. Above the principal diagonal means I value is less than j. Below the principal diagonal is I value greater than j. On the principal diagonal, I value is equal to j. So you see the suffixes 1, 2 means 1 less than 2. 1, 3 means 1 less than 3. 2 less than 2. Okay.